Okay, good morning, everyone. We have already waited for 5 minutes. We can start now. So welcome to this course on artificial intelligence. All of you are here. There are supposed to be 60 students. About 50% of you are here. Anyone has a comment on why there are so many absentees? I'll allow you to unmute yourself. So if I feel there is a lot of disturbance, then I'll withdraw those permissions. But for now, everybody has permission to unmute and speak when they want to. So in general, will somebody comment on why the attendance is low? Has everybody received the link to this meeting? Those who are here, of course, they have received it, but have you heard of any complaints from anyone who has not received it? Are you people here? Let my class be a bit noisy in the sense that I hope this class will be a little more interactive than your maybe other regular classes. I would like to take your inputs, so you will drive the direction in which the class goes. So you're welcome to speak in an orderly way. The class is big, so sometimes if everybody speaks, it will be difficult to manage. But within those manageable limits, everybody is welcome to speak and participate in what we are discussing. So no comments about this. So let me first explain about this course. So this course is about, as the term suggests, the artificial intelligence, a very important area of study these days. But it has always been important. And we'll talk about what intelligence is, what people think in the field of psychology and education, what they think is intelligence, and how people have understood intelligence even prior to the computational intelligence. Then we'll come to the artificial intelligence. What is the artificial aspect of the intelligence that we are trying to study, whether machines can be intelligent or not. So these kind of questions we'll discuss. And then we'll come to specific techniques which are implemented in the field of artificial intelligence. So I'll share my screen to first let you know the textbooks that I follow. When I teach a subject in which I'm not very confident, I follow a textbook. So that's what I'm trying to do. These three books will form the primary source for what we discuss here. At least the structure of the topics that we cover will be taken from this book by Russell and Norvig. This is the primary reference for our classes. And then there are additional support books, which will basically give you examples on how to implement these AI-based techniques and tools to solve real problems. So there are two books. One is for Python Beginner's Guide for Artificial Intelligence. Those who want to go more advanced in this same book has a compendium which is called the Python Advanced Guide for Artificial Intelligence. But we'll use the beginner one for this course. And then there is another book by Dennis Rothman, Artificial Intelligence by Example, which gives you a list of projects and examples that you can study for this. So these three books, primarily the second and third book, I may not encounter freely. Maybe I'll take them at will. But the structure of these lectures here will primarily be following the contents of the first book. But even before I start the contents of that book, I would like to take a little overview of what people think about intelligence. And when I say people, it means a common man, and it also means the academicians of different fields and the professionals who have been studying intelligence for a very, very long time with a different purpose, not to design intelligent machines, but to assess people's intelligence and to provide them specialized guidance. So for instance, IQ tests have been there for have been prevalent for a very, very long time, and people have designed intelligence question tests. So what kind of questions should be there in IQ? And at what level you can score that an individual has 100% IQ or 120% IQ, and what are the implications for designing a course curriculum for them. So this has been a topic of interest for researchers, for educationists, and for policymakers for many, many years. Machine intelligence, which is a preferred word for me, instead of artificial intelligence, I would say machine intelligence. if given a choice, but being consistent with what people use, I'll continue to use artificial intelligence, but I would prefer the term machine intelligence. Is relatively new, but it has become possible because of the advancement in the computational technologies. So we'll come to this point. But before I give you what intelligence is, let me ask you people what you think is intelligence. Let me take your inputs, and then I'll go off my slides and take your inputs and discuss this point, what you people think is intelligence for you. Give me your inputs. Anyone can unmute themselves and say if there is if more than one people are speaking, then I'll choose. But if only one person is speaking, just feel free to unmute yourself and give your inputs. Anyone? What
So
do you think is intelligence? Yes.
abstraction.
Sparsh Tevatia, yeah. Can you
Yes.
say this? Say it properly. So what do you mean? What do you think is intelligence? What is
So,
an intelligent act? Yeah.
yes, sir. Intelligently solving problems, like finding solutions.
So finding solutions is one thing that you
Fostering
think is
solutions.
intelligence,
Yes,
problem solving. So in your definition of the term, intelligence is about problem solving.
yes, sir. And also abstractions, making abstractions out of
Okay,
patterns.
making
Yes, sir.
abstractions out of patterns. Okay, so two things you pointed out. One is making abstractions. Perhaps making abstractions will come first if you have to order these two things. Making abstractions from observations. And second is what you said first is about solving problems.
Yes.
Okay, any other inputs?
So learning.
Yeah, so learning is, how is this learning different from the first one that we just discussed? They making abstract patterns from individual observations. How is learning different from this? You think it's different?
No, sir, not difference.
Probably the same,
Yes,
but
sir.
yeah, you also attribute to the idea that intelligence means learning or formulating abstractions of patterns from individual observations. I would welcome everybody else's inputs, and you can give me examples, and perhaps we can elaborate what are the acts of intelligence and what are not the acts of intelligence. So let me take some example. Let us say I know the names of every student in JNU, and I can recognize them by looking at their face, and I have all the information about them. Is this an act of intelligence?
No, sir.
What do you say, Sparsh? Yes or no?
No, sir. No.
It is an act of intelligence?
No, no.
Does everybody agree this is an act of intelligence when I know name of every individual? Which part? So there are two parts of it. One is knowing the name of every intelligent, and second part is being able to recognize them. So both of them are acts of intelligence. Ritika, you were saying something? Yeah, go ahead. I would like you to participate and let us discover these ideas together. Let me tell you one thing. When we learn a lot of theories and all, most of them we can discover ourselves. We don't need to actually somebody teaching us. All we have to make our efforts is to really take the same course and discover themselves, discover them ourselves. That is the best way of learning. So coming to this question, this act of knowing every individual name, I have in my brain name of every individual, their corresponding phone number, email address, or whatever details I have. I have lots of details. So is this an act of intelligence?
No, sir.
Yes, Divansh, you say it is not an act of intelligence. Why do you say
Yes.
so?
Because that's a part of, like, that's the retaining capacity of your brain. That's not intelligence.
That is retention. That is memory in you think it
Yes.
is a memory. It is not
Yes.
intelligence. So you are already making a hypothesis that memory is not intelligence.
No, sir.
What do other people think? So now the question arises, can there be intelligence without memory?
So I think there should be some kind of reasoning involved. The memory, there should be some basis to what the decisions have been taken. So that should be intelligence, according to me.
So ability to reason is intelligence in your view. So we have collected this we have studied so far from our discussion, 4 points have come forward. One is the ability to solve problems. And there is a broader agreement that this is intelligence. Second is the ability to form abstract patterns from individual observations, the ability to generalize things. So generalization, it leads to abstraction, abstract formations and abstractions in our brains. So then that is an agreement that is also an act of intelligence. And the third thing that we discussed was about remembering a lot, having a lot of information in your memory. There is a little mixed opinion. People are not very happy to call it an act of intelligence. Is this right? So in some sense, cramming up or mugging up information is not intelligence. You all understand this.
Yes, sir.
But we need it, right? We need it for solving problems. I mean, if we say solving problems is intelligence, can we solve problems if we have no information?
Yes, sir.
We cannot solve problems without information. So information is required to solve problems. So but in memory or information itself is not intelligence. Putting this information into use and making abstractions, enabling ourselves to solve problems will be intelligence, right? So can you think of something else? So the fourth one that we just talked about, somebody said, was some sort of reasoning is involved. So how is reasoning different from forming patterns? And what do we mean by reasoning here?
So there's some logical conclusion to it. Is not directly based upon that, but we are making inferences and
yeah. So, but this
then,
logical representation of logic in our brain is some kind of an abstraction, isn't it? Because logic resides in our brain in the form of abstractions. So individual observations, we say, if we put a lot of, say, just think of a small child and you are giving two objects, one of them is larger than the other. And you ask child to tell us which is larger. So you give him 100 pairs of objects, and there is a child who can distinguish between the larger and the smaller of the two in each pair. There is one child which can do this with 100% accuracy, and there is a child which achieves this classification with 80% accuracy. Can you conclude that the child which achieves 100% accuracy in this classification is more intelligent than the one who achieved 80% accuracy? Yeah, can you tell me this?
Can you repeat the question again?
So my question is that you want to compare two children. One of them is able to recognize a pair between two pairs of objects, which is larger than the other. And another achieves this with 80% accuracy. So just repeating the question, I think in a simple way, I have 100 pairs of objects. In each pair, one object is larger than larger than the other. And now I ask child, I give a pair of objects, ask him to tick the one which is larger or tell which is larger. So now there are two children. One of them achieves 100% accuracy in this classification. And there is another child who achieves 80% accuracy in this classification. So can you from this conclude that the child who achieves 100% accuracy is more intelligent than the one who achieved 80% accuracy? It looks more natural to think yes, right? Because one is achieving 100% accuracy and one is achieving only 80% accuracy. Is there any caveat to this? Is there any limitation to this conclusion?
Yes, sir.
Yeah. So can you tell me what?
For example, sir, it depends how many trials the child has undergone. Maybe that
No, just once. I give a pair of objects to the child once, ask him which one is correct, and he gives the correct answer.
no, sir.
Just
Before
give me a
he
second.
has,
I've received some complaint that some students have not received the link, so I'm sending the links again. Just give me 2 minutes to complete this process. Okay. So I have resent the confirmation to everybody. If any of your friends is facing problem in joining, just let them know to check their email again. Okay, so coming back to the discussion that we had. So who was speaking?
yes, sir.
Yes, Persh. So what were you saying?
I was saying it would depend on the memory of the child. Suppose he has been asked this question like before,
Hmm.
how many trials he had performed earlier, not
Hmm.
like just before that, but how many times he had judged that which object is larger or not. In that caveat, if one child has more data, then we cannot say that he is more intelligent or not. Because
So
in
you are saying there are three things in this already computationally also. One thing is how much data was used in learning the size comparison. So that is what you are saying. So second thing is the learning, how much learning is involved. And second thing is whether the objects that you are presenting to the child, are they exactly the same object that the child has seen before?
yes, sir.
If
It,
the child has already seen those objects before, he will be able to achieve a higher accuracy without being intelligent, without having to use his intelligence. Maybe he's still intelligent. I cannot conclude that he's not intelligent. I can only conclude that his answer is more accurate because of his experience, because of his previous observations, and that just what he's doing is the child which is giving 100% accuracy is basically searching for the information in his brain which is well represented. Because even if he has seen these objects and he is able to repeat um, answer correctly, and he is able to recognize those objects which has seen in the past, which requires some kind of intelligence, right? There will be many children they will not be able to do it. But he is basically, in this case, when he is not making any abstractions that we already discussed, he's not making any abstractions. What he's doing is basically he has a database, and his answer is based on a database search. So he's when you ask him which is larger, he will just compare in the pairs of objects. Perhaps he does not suppose you are giving him objects, one is spherical and one is square. You are asking which is a larger size area. So perhaps in his brain he has represented that a square is bigger than a circle. And this is true because the 100 objects you are presenting to him have that property. But so that is the caveat. So whether he has really acquired, whether he has learned something, and in the process of learning or memorizing, whether he's answering the question based on his memory through recognition process, or whether he's answering his question by forming abstractions and calculating area as a thought experiment in his mind, and he's able to in real time generalize how to compute the two object sizes and tell which is bigger. Now, which object is bigger is a very general question. So what kind of questions I form based on this? I give only rectangular objects, whether I give them spheres and the three-dimensional objects also. So there is an entire set of details in this, based on which the questions like IQ tests are formed. And IQ tests, when they are formed, every question is assigned, okay, this is the kind of answer we expect a 3-year-old child to answer or a 4-year-old child to answer. They are detailed research papers on this, and then based on that an IQ test is formulated. Again, there are issues with that, but here we are trying to conclude that that memorization and answering from memory requires some level of intelligence, because the use of memory it is equivalent to database search in computational sciences. So it requires memory after all, and memory cannot be utilized without proper intelligence. Now, how well the child is able to represent his knowledge becomes a part of question of on intelligence. So to my original question, whether a child who is able to answer the questions with 100% accuracy is superior in intelligence than the child who achieves only 80% accuracy is not guaranteed. This answer is not guaranteed. This based, as you rightly pointed out, it is based on multiple factors. On number one of them is whether the objects we are presenting to the child have already been seen him and he already knows the answer for them. So this, I also clarified that even if he is able to answer it from his memory, it does not mean that a person with zero intelligence can answer this. But this requires relatively less intelligence to pick up the answer from the memory. Secondly, even if these objects have never been seen by the child, then how long the child took to learn to compare the area. So whether the child is just skilled or is intelligent, that is the question here. So everybody who has a skill to answer a good question is not necessarily more intelligent. People who can do x square plus y square and write an answer, they do it out of training. They don't do it out of intelligence. A child who is not able to do x square plus y square because he has never seen x, y, these kind of equations, is not necessarily less intelligent than the one who is able to quickly solve these mathematical problems, or any advanced mathematics, the calculus or integration or differentiation, or any problem of computational sciences. A person who is able to do this, achieve something, is not necessarily more intelligent. So coming this, what it demolishes our idea is that problem solving is not necessarily, there is no one-to-one correspondence between ability to solve problems and intelligence. Do you all agree with this now? Or if do not agree, you give me your arguments.
Sir, abstractions are used for problem solving, right?
Yeah. No, abstractions are not necessarily solved only for problem solving. The abstractions may be used for multiple things. I'll come to formal theories. There are psychologists who have studied these issues in details and come up with very nice abstractions of these discussions that we are holding now. So we are holding discussions in a patchy manner. So psychologists, when they formalize this knowledge, they form abstractions so that you can study and think in that framework. So why I'm allowing you here is to think out of any framework first, and then we will put the framework for you. So there is a question in the chat box. Is there any relation between training and intelligence? Let me hear from what you people think. First, I'm trying to generate your common sense and then trying to aggregate your common sense about these topics. Then I'll share with you what I have read, and share with you what other famous psychologists who worked on these areas, what they have said about it, and how they have formulated and this subject, and how they have created abstractions from this about this subject. So we are studying abstractions of study of abstractions. So this question, let us discuss this question. Somebody asked, what is the relation between training and intelligence? What does your common sense say?
Sir, I guess training is more related to reducing an error on a certain task. Say I am trying to recognize something as like a bottle. Firstly, I'm not able to do that, but like with time and with more examples, I'm trying to reduce the error and trying to classify the bottle as the best way I can.
So with training, my ability to solve problem improves, right?
Yes,
I
it
gave you the
does.
example of solving mathematical problems. So when I get trained, I can answer those questions. I can solve these problems much better. So does this mean my intelligence level has increased?
Sir,
Hmm.
can we think like if we are trained in highly sophisticated skills like mathematics or coding, which require highly abstractions, uh, then it should improve our intelligence. Like for example, the body adapts. For example, if you do cardio daily, if you do strength training daily, your body adapts. So if you do mental training daily, like highly abstract thinking daily, mathematics or coding thing, then your body should adapt, your brain should adapt. You should become more, uh, but we cannot say it properly. Like we have to do more and more trials to formulate this.
So your underlying assumption is that as we become more skilled at doing something, we can solve problems better. I mean, doing sports, scoring more runs in cricket through training, we become more skilled and we can solve better problems. We can deal with a faster ball. We can deal with a ball which is spinning more, and we can use our footwork. This all comes through training after practice. So practice is some kind of a training to your body, training to your mind, and training to your reflexes. So these things that you develop, so your assumption is that this improvement of your bodily movements and bodily reflexes and the thought experiments, if you do this, if you move your bat like this, that is where the ball will go. You are doing thought experiments and you are projecting what will happen if you do this, and based on that you take a decision. So your ability to take correct decisions or solving problems improves because of a constant training, constant experience, or constant what you call learning. So what you're saying is that this is also improving intelligence, right?
So I'm saying like intelligence, intelligence depends on brain circuits, like the neural pathways and the energy supply to the brain, like how much oxygen you are getting. If we are thinking,
Just a moment, let me again, there is one more request for fixing somebody who is not able to reach the class. So this is just a little teething problem for the first one. Okay. So Ishan is Isha. Are the two people different people or the same person? ISH.DHA is the same as Ishan.
Yes, sir, they are same.
Yes, sir, I'm in.
Okay, so he's in now. Great. So continuing, what were you saying, Sparsh? I think you were speaking.
yes, sir. Sir, I am saying, like if there is a healthy body,
Yeah.
like you get more energy supply, more oxygen to your brain, so your intelligence should improve. Intelligence is depends upon the circuits of your brain.
Hmm.
So by training, you are enhancing those circuits by using your brain more and more, by using those circuits which are required for abstraction more and more. Your general intelligence should improve. That's what I'm saying.
Yeah. So what you're saying, no, there are two things. One is your intelligence improving because of your experience and due to your training, and one is improving because of the physiological changes in your body, which may be good health, which may be better blood flow, or which may be an implanted brain. So whatever are the factors, one is the physiological change where the bodily changes, physical changes happen in your brain. And the other is giving more and more experience, more and more data, and letting those experiences improve the connectivities in the brain. If you, since you have most of you have also studied machine learning to some extent, this is equivalent to having an architecture of a neural network, which is like a physiology, and giving the data and training the model for a longer time, larger number of iterations and larger amount of novel examples. So this is the equivalence you can see there. So in the process of training a machine like neural networks, just although machine intelligence will come later, but just since here the discussion has come up. So do you think a machine becomes more intelligent after learning? Or a human beings become more intelligent after learning? or when we define intelligence, should we eliminate the contribution of learning in our ability to solve problems? So this is about the way we define it. I mean, if we say, okay, our intelligence is, if we are hardly mapping it, hard coding it, to say that every ability to solve problems, and here when I'm saying solving problems, it is not just solving mathematical problems. It may also be sports problems. It may be also problems of impressing somebody. It may be any problem of life. So solving those problems and being able to do a certain do certain tasks with a better efficiency, a better performance, is problem solving. So just can we say just somebody who can solve the problem better is more intelligent than the person who is unable to solve the problems? Or we should eliminate the role of learning from this when we call something intelligent?
So I guess it's more related to the interpretation of the problem.
Yeah, but how would you like to interpret it?
So
The subject has
like,
become kind of more standard, so people have already reached some consensus. So should we treat intelligence separate from learning, or should learning be treated as a component, as a part of intelligence?
well, intelligence, learning can be a subset of intelligence. It's not basically
Your
direct.
voice has
We
cracked a
can't
little
just.
bit. Devyansh, your voice has cracked a little bit. Can you repeat?
Is my voice clear now?
No. I can't hear you well.
Hello.
Yeah, please say again.
So I was just saying that learning can be a subset of intelligence.
Yeah, so there's one comment here in the chat box. We can keep learning, but the skills learned from this learning can be used
Say
for
when we
to solve
train
other
it,
problems here. So this is, see, all this what we are discussing are used in a very sophisticated manner, in a very powerful manner in computational sciences. When we are saying what we learn in one in a skill can be used in another, has been traditionally known by the psychologists as transfer of learning or transfer of training. So for instance, if we learn to drive a motorbike, and now if we want to learn to drive a car, there may be a positive transfer of learning. But there may also be negative transfer of learning, transfer of training. So one skill that we learn that may interfere with the way we want to do another task. So there will be a negative transfer. So so the skills that we acquire may sometimes be detrimental to the new skills that we want to acquire. That is slightly different. That is not a topic of intelligence. That is a topic of learning, how we learn and how the learning can be incorporated, how one set of machines that have learned can be utilized in another learning. So in the deep learning, there is a very elaborate concept, and now it is a very powerful technique in deep learning, the idea of transfer learning. This is one of the reasons that deep learning is so popular now, that has made it so much faster, that you train the machines, you train your deep models on one set of images which are totally unrelated to a new set of images, but that training may still be utilized for solving another problem. So in some sense, you can utilize them as an initialization of neural networks. So you do not have to start from scratch. So training time can be saved and performance can be saved. So these ideas are used in a very sophisticated, in most recent technology in computational sciences. But psychologists have studied this decades ago as a concept of transfer of training. Yes, so Divyansh, as you write, so transfer learning is restricted to particular domain. Of course, transfer learning is, you can only transfer learning from one field to another if this has some common elements. If the two fields are completely unrelated, of course, there is no question of transfer learning. It does not mean that if I undergo a lot of training and I am used to being trained and I have trained myself in a number of skills, then these skills may not be utilized in another case. But I in fact generalized it more. So sometimes there are some hidden similarities between two tasks. I learn one task and that learning may help me to perform another task better. Sometimes I may not realize how it is helping us. So, and I already said that this learning can be negative also. What I learn in one scenario, in one context, in one domain, may harm me or may reduce my ability to learn another skill. So, for instance, a quick example, a rough example could be that if I have a bike in which my brakes are on the right hand side, and if I have a bike on which I have a brake on the left hand side, or my steering in the car is on the left of my car or the right of the car, or if I'm driving on the road in a country which drives the cars on the right lane and the one which drives on the left lane. So these are the examples of negative transfer of training, negative transfer of learning in our brain. We learned something, but we cannot take it to another situation because it interferes, because we have to unlearn what we have already learned. So that is because our reflexes have developed, taking one particular context, one particular environment into our mind. This is slightly distraction because this is not really about intelligence. This is about learning, how the learning affects us. So my question was, should I include learning to be within my definition of intelligence, or should I keep it outside and treat learning as a separate component and intelligence as a different kind of an abstraction? That was my question. So there are some thoughts that you have given. So it depends upon the definition. But what do you think when you say somebody is intelligent? Are you including his learning, his experiences, or you are excluding them? You are saying them inherently he is more intelligent than the other. Then you do a machine learning. So how many of you have studied machine learning? Can you just raise your hand so I can count? So there's no machine learning course so far in your...
Only for CSE. Last semester in CSE we have studied.
So last semester you have studied, right? So you have the broad understanding of what machine learning is.
Only computer science students, sir, not electronics.
Oh, CSE, okay, computer science. But these days, machine learning, some ideas are also taught at an earlier stage. Like in school also, they must be teaching you some basic ideas of machine learning. Isn't? No? That's fine. So I assume that you have no experience with machine learning. So I will use those terms which can be understood by even if you have no experience with this. So there is one comment in chat box. Can we say this as intelligence? Coding makes us to think logically. So this logical thinking ability can be used to make decisions in our life. So, I mean, this may be an example that if you solve coding problems, you draw examples from totally unrelated situations. Interestingly, this is indeed drawing inspirations from totally unrelated situations to new situations is considered by behavior scientists or psychologists as some form of intelligence. And when people design tests for testing different types of intelligence, one of the intelligence they test is also creative intelligence. So creative intelligence is tested by two types of experiments. One type of experiment is given that you are given an object and you are asked to think of new use case scenarios. This is an object, this is the current use. Tell us what else you can do with this. So a divergent thinking about the creativity. And another is a sense of creativity is you are taught totally unrelated things and can you connect them with one another. So this is a convergent kind of a creativity where you unrelated items which your experiences, totally unrelated experiences in your life, you draw inspiration from one experience and you try to solve the problems of another. So this is the kind of thing that you are saying, that you learn coding, but since coding develops certain kind of a logic in your mind, so in your real life situations you apply that logic and you try to solve those problems. Or you study biology in some places, and that's how people have achieved great success in the field of artificial intelligence. They study biology, they study the theory of evolution, they study how the cells work, they study how the brain works, and then they try to implement on machines. This is an example of these computational scientists who learned something and they drew inspiration from that learning and solved a totally new problem. How to solve the computational problems, how to solve the optimization problems, how to calculate the differentiation, how to calculate the area of a particular geometrical surface. So all this, they draw inspiration from many biological subjects that originally they were not meant the biological systems that were taught, the theory of evolution that was taught, the genetic algorithm that was taught, and genetics that was taught, it was not aimed at solving computational problems, but people studied two different things. They learned something from one and implemented to another. So this is a kind of connectivity. Can your brain connect different experiences? And this, many psychologists believe that this is a very strong, very important component of intelligence. And when they design an IQ test, they design that kind of a question, that they incorporate these kind of questions, which can make you, which can test whether you can do divergent thinking, whether you can do convergent thinking. And then people have already also done surveys and concluded that if your IQ is less than 120, there is a relationship between intelligence and creativity. But if your IQ is above 120, then that relationship breaks down. There is some kind of an argument on that. Some people say this. Some of those interesting ideas I'll share with you, and I'll give you some links if you would be interested in learning more about it. So continuing this discussion, so we come back. So we say that the ability to solve problems is intelligence. Ability to form abstractions is intelligence. And ability to recognize and extracting information from what we have experienced in the past is intelligence. But probably learning itself should be kept slightly different from the intelligence, because by a less intelligent system can learn more, and a more intelligent person can learn less, depending on how much training is provided. So here the amount of data used for training also becomes important, and that happens in the case of machine learning as well. If you have more data to train, your models become more capable and can solve better problems. The core thing is that when you design the computational system, the architecture, when you design a neural network and you say that I'll put 100 nodes in the input and I'll put 20 nodes in the hidden layer, first hidden layer, 10 nodes in the second hidden layer, and so on. So I am defining a particular structure of my model or my system. Is this system intelligent? Can I make this system intelligent? So that is, the systems themselves may be intelligent. And then after you have designed the framework of an intelligent system, you will incorporate, you will try to find a way to train them to solve the real problems. But intelligence is required. There will be some people who have a zero intelligence. So you give them any amount of data, they will never learn. So, and there will be some who can learn very fast. With a small amount of data, they can learn more. So somebody who learns more, who has the ability to solve problems with less amount of experience and less amount of training, is definitely more intelligent than the one who learns less and who reaches the same level of problem solving by less amount of data. So this is, or more amount of data, I don't know which one I said first, I lost track of my own sentence. So but you understand the point. So the amount of data that you are giving to the system and the amount of iterations that you are letting the system to undergo to become expert in solving problems is what is at the core of the heart of the intelligence. Now let me, this was my general discussion. Let me take now to you to what formally people have thought about, and share with you some links that you can be helpful for you to follow through this discussion. So this is a figure. There is a nice link, and in a briefly, this website, verywellmind.com, they have some theories of intelligence which you can read. So what it says is there are three components of intelligence. One is the ability to learn. See, learning itself is not intelligence. It is the ability to learn which is intelligence. So that is why we are separating learning from intelligence, but learning is connected, very well connected to solving problems, because without learning, a very intelligent machine cannot solve any problem unless it has learned to solve problems. So learning is important, but intelligence plays a role here, that if the machine is not intelligent, or if the individual is not intelligent, he will never learn. So we should focus on the ability to learn, then the learning itself. That is what the intelligence is all about. Then the second is the ability to solve problems. This we have highlighted and discussed significantly in just now. And the third is the ability to recognize problems. We interact with our environment and we say, oh, there is something wrong here. So here nobody is posing you a problem. Here nobody is asking you to solve a problem, but you notice it. You recognize that there is something wrong. You recognize that there is an opportunity to improve something. So it is not recognizing problem means nothing, not just the recognition of disasters. It is also the recognition of opportunity to improve the lives better, opportunity to make our ambience more aesthetically beautiful. So this ability to recognize problems, when I'm thinking of problems, I'm not just talking about the problems that are haunting us, but also an opportunity to improve our surroundings. So this is the three components primarily which psychologists define intelligence is all about. But then people have gone, the psychologists have done much more than just putting these 3 points together. So I have discussed them, but let me elaborate this. These people have elaborated. When we say learning from experience, then what does it entail? It entails acquisition of information. Once you acquire this information, then this information has to be retained in your brain. It should not be that today I learned something, tomorrow I forgot. So our ability to learn from experience, we call learning is, now how do you define learning? Let me ask you yourself. What do you think is learning? You already used in your discussion the meaning of learning. When do you say a machine has learned or an individual has learned? Can you give a formal definition of learning, as formal as you can, without having seen the definition before? Anyone? Just try to say anything. It does. You may say something totally wrong. It is okay. At least try it. Show your intelligence.
Sir, studying to develop a skill or knowledge of some sort is learning.
No. Studying is a process of, what you are saying is a process of learning. But when you say you have done learning, so what do you mean when you say that learning has been done or learning has been achieved?
Sir, basically acquiring some knowledge.
Yeah, Sania, you also said something. Can you say?
Yes, I said the same thing, acquiring the knowledge.
So acquiring the knowledge is enough?
Prediction, sir. Prediction accuracy.
Sir, accuracy isn't related to learning necessarily.
No, prediction and accuracy and everything they may be learning, but these are kind of individual examples of learning. Can you make an abstraction? That is, I'm testing your intelligence here now. Can you make an abstraction of what you think is learning?
Like an example we discussed. Like for example, if there are two children, we give them different shapes of objects, and then we ask them, then which one is bigger volume, and then they use all the data they have.
So this is an example you're giving. Can you generalize when you say that this person has a lot of learning, he has undergone a lot of learning, or this system has learned a lot? What does this mean?
General awareness, sir.
General awareness is not learning. That is what I explained to you. General awareness may be simply a collection of information. Collection of information is not learning. It may have to some component of learning, but just imbibing a lot of information is not. We already discussed this, that this is based on memory.
Sir, internalizing of application of a certain knowledge or skill.
So like, I mean, let me read this from chat box also. Identifying problems similar to what we learned. No, this is learning, yes, but in the sense what happens to a system that has undergone learning. So what people have defined in psychology before, and this is applicable to you. So you have a machine learning model. You have, say, you define a linear regression model, or a neural network, or a deep learning model, or a random forest, or whatever computational model you have defined. So this is an intelligent system. Now, when you say this intelligent system has learned, what does this mean? This means relatively permanent change in the parameters of the system. That means, so as on the slide you see, there are three components of this. One is the acquisition of the information that is equivalent to your memory, that this goes into your brain, and retention of that information. Sometimes we learn on, get that information, we forget about it. Like your RAM, you switch off and everything is gone. So RAM does not learn. RAM just stores information for the time being. And when you put the data in a hard disk, does hard disk learn? Hard
So,
disk has a lot of information. Can you say that hard disk is a trained machine?
so
No,
sir,
sir.
is the algorithm the learning? Because the algorithm changes with every point of data, the parameter changes. Is it the learning, sir? The algorithm?
So basically, when you say learning in this context, is that it brings about relatively permanent change in the system that is learning. It can be a permanent change, maybe in terms of the parameters. This may be just a soft machine that has learned. So a set of parameters in a regression model, the regression coefficients are the indications of learning. Whether the learning is accurate or not, that comes from the performance measures. But when you say it has learned, means after the learning, the set of the regression coefficients that were there in my model before I trained it, and then after I trained it, this set of parameters have undergone a change. So since they have undergone a change in a way that they can help me solve the problems, we can say that this system has undergone learning. Same way our brain may create new connections, or it may connect, may undergo some rewiring of my brain, so, hypothetically. So this kind of changes, relatively permanent changes in an intelligent system, are learning. And then so this is ability to learn. So some systems have no ability to learn. So if I create a completely random model and I take the input of the data and put it to a machine which can just randomize them, so it will not learn anything. So like if I have a regression model and I have n set of features that produce m set of outcomes, so mapping from the original n values to the output m values, this is an intelligent machine. But this machine I can create some kind of a matrix which transforms the original n inputs to m outputs. This machine will have to learn to be able to solve the real problems. But if this machine has my model has been defined in such a way that it has no ability to transform the n dimensions to the small m dimensions, then I can say that this machine has no ability to learn. So ability of this machine to learn is what will make it intelligent. And the process of training the machine, you can call it is a trained intelligent system. So this is what it is about the learning part of the intelligence. Second part of this is about noticing. I already explained to you briefly that to identify the possible problems in the environment. And I expanded this question a little bit, that when I say recognizing problems, I should also be able to include in this definition our ability to identify the opportunities to improve, opportunities to make our life more comfortable, opportunities or the ways of thinking of helping others in a better way, and improving the aesthetics around us, improving the comfort level of our working. These are not really problems. I may be totally comfortable in this scenario, but I see that this can be improved, this can be done faster. And that's how these civilizations move to identify the opportunities, not just the problems. And solving problems, we have elaborated this significantly. So now another query here is from Devyansh. The machine has no interpretation of what is it doing. It is just a mapping process. So how can that be intelligent? So let us discuss this point. This is an interesting question. So if the machine does not interpret the way it is solving problems, can we say it is not intelligent? This is a very important point, and let us work it out and work it around by building a consensus amongst ourselves. So when I go out and meet my friends, and I address each of my friends by the name, and I exactly know which friend I'm talking to, who is that person. So what I'm doing in this process is the third part of the intelligent system that I mentioned about, is the recognition part. So my ability to recognize who is who, or mapping the name, or mapping a whole profile that is in my mind from the visual input of information, visual input of information. I look at the face of the person. By just looking at the face of the person, that visual information is immediately mapped to a profile that resides in my brain about that person. So it is about the name, about everything that I know about that person is stored in some kind of a profile, some kind of a database that is related to that person. I never mix up. I never confuse between my friends, who is this friend, who is that friend. So this kind of mapping, do we know why I am calling this friend, that this particular friend is Mr. X, and this particular friend is Mr. Y? Do I say that, do I know what features are making me conclude? Just give me a second. Yeah. So do I ever measure the distance between the eyes? Although my brain has the ability to distinguish if the two eyes are, if the person has narrow eyes, if a broad eyes, round eyes, nose, color, complexion, etc., hairstyle, dress, makeup, etc. All these things, all the time I use them, but I never interpret, and I never need to interpret why I recognize a particular friend as a friend. So the representation do not have to be in a conscious and interpretable model. So interpretability of a model is not required for intelligence. There may be some hidden representation in my brain. So same way for machines. So machines may be able to answer a question without having to explicitly be able to interpret them. A mathematical model is more interpretable, but it may be less intelligent. It may be less capable of answering my questions. So intelligence is not directly related to the interpretability. Interpretability is only useful if it helps me improving my answer. Otherwise, what is the point in interpretation if it does not improve my answer? So that is where the difference between the intelligent system and the exact mathematical system is. A mathematical system is different from an intelligent system. A mathematical system has a relationship of exactitude. You give this input, and this will be output, and you know exactly how this output is coming from these inputs. A mathematical model may be intelligent in certain scenarios. It may be able to solve the problems, but it is not a requirement for solving problems. There may be many models, and in fact, a large number of intelligent models are not directly interpretable. That is the answer to your question. So I think I'll stop here. I'll take more questions if you have any for the discussion for a few more minutes, then we'll close today's class. Anything you would like to say? So in the next class, I will come to the formal theories of intelligence and how it has evolved. And then subsequently, I'll discuss other topics. So in the artificial intelligence, just to put this together, there are two components. One is the intelligence and one is the artificial. So what we are talking about is the intelligence part. Then we'll talk about what is the artificial part in this, why it is artificial. As I said in the beginning of my lecture, that I would prefer to use machine intelligence instead of artificial intelligence. Yeah, somebody raise hands. Shruti, you raise hand? You have a question?
By mistake,
Yeah.
sir. Sorry.
Okay, fine. Okay, then, if there are no questions, we'll close the class for today. I'll announce you about it next time. Okay, so somebody asking, sharing the recording of this class. So I have recorded this class, so I think you have noticed. So I'll share that. I'll put it on YouTube. And so we have a YouTube channel on SciWi Lab. The YouTube channel is known as SciWi Lab. This recording I'll place there, and you can listen to this again. Okay, thank you for today. See you next time. So please be regular in the group in Telegram, because most of the class timing and all I'll share there. Thank you.